Welcome to the class of Introduction to Software Engineering. Today we will discuss and talking about software design. It's one of the software engineering activity that we have to consider much. Okay. Software design. There is in software design there is interesting part of the software engineering that is about designing, translating from the requirement to be designed before we can implement the design. Okay, this is the short definition of software design. In software design we have principles, okay, concept and practice of the software design that we have to understand and then fulfill each requirement. For example, here they say that software design encompasses of the set of principle, concept and practice that lead to the development of high quality software or high quality product or high quality system. Okay, we have software principle that guide you to do the software work that you must to perform. A software concept must be understood before the mechanic of software practice. Okay? The concept such as what thing that you had to follow, what thing that recommended to you to do in software design, because software design concept, and then software practice is applied from the software to do some kind of the model. Here we can the output of software design is the software model. Okay, software model in terms of architecture or low level component such as. Okay, if we look at the layers of software engineering, software design is in process layer we have design engineering, and in the method layer we have design method that we can implement both structure design or object oriented design. This is the famous and the essential part of the software design. Mostly right now they are focusing about object oriented design. Structure not too much they are focusing right now, because structure is for something that the old way, you can say that the traditional way of the design, but right now is there much of the tutorial or book or resources they are focusing on about object oriented design, and also we are focusing on object oriented design also in this class. If we look at the design in the software process, is the design is between software requirement and software development. There is design between, so it means that we have to understand the requirement. It related to how to get the requirement, how to write documenting the requirement, and then we will have the requirement analysis that we will represent in terms of some kind of model such as use case diagram. Okay, use case diagram. So after we got that diagram, so we have to pass to the design, okay, to design the system in terms of high level or low level, and then we will discuss about this one. And then after we design, we pass the artifact or the product of the design to the development. Okay, this is the step of the software design that related to requirement and development or implementation. The main topic today is about because we already discussed about software analysis, okay, requirement analysis, and that we got requirement from the user, stakeholder, and so on, that user that related to the software. Then we have to translate the requirement analysis, the model, to the design model, okay, in some kind of representation. Okay, some kind of representation. Okay, let's compare between analysis and design. You see this one, analysis is about what, okay, design is about how. Okay, the analysis is translating the functional requirement into software concern. In design, the functional requirements are translated into software component. Okay, this is another vocabulary that you have to to know about. This is we call software component. Okay, software component. Non-functional requirements are listed and quantitatively. In design, non-functional requirements are the core focus. Non-functional will be the main focus on design, okay, such as security, performance, scalability, and maintainability, something like that. Implementation independent in analysis, done at different level of abstraction. For example, the design should do architecture design, pattern design, technology design. This is about the design that we have to consider during the design phase. Okay. From requirement modeling to design is we consider about analysis, model, guide the design phase to something like this. Okay, use case model illustrate what are the system functionalities. This is what we have been discussed about the requirement analysis and modeling. Class diagram show what are the major major conceptual classes and relationship between the functionalities. Okay, interaction diagram show what are the need interaction between the conceptual classes. State machine diagram show what are the events that change the state conceptual diagram, and non-functional requirements are clearly defined. This is in terms of requirement analysis and modeling that we are using several diagram, use case diagram, class diagram, interaction diagram, state machine diagram, and so on. Okay. From requirement modeling to design, so we use that notation so to serve some kind of level of design to the following question. For example, as how our object group into sub level component. Okay, because design they are much little bit low level right now to the component. Okay, there are how this component structure, how the component interact design, how the component interact between another component, how component satisfy the non-functional requirement. Okay, the security and availability, something like that. How the inner classes this component design, how are the inner classes related, how do the inner class interact, how event and state affect this inner classes. This is the thing that requirement modeling try to help the design. Okay, from the requirement analysis and modeling, we have many artifacts, we have many requirements that represent in terms of use case. For example, it represent in terms of activity. So in that level, we call the class diagram analysis class diagram. Okay, activity analysis activity diagram. Okay, those diagram we can use also in design. We call activity design activity diagram or design class diagram. Okay, they just add a little bit name in front of the notation. Okay. Translating requirement model into the design model. For example, here we have the left hand side is analysis model, the right hand side is design model. You can see here we have scenario, behavior, and class-based element. In the behavior we have state machine. In scenario we have use case diagram, swimlane or sequence. Class diagram we have class. Okay. The collaboration analysis package, something like this. They are mapped to between analysis and design model. From for example, from use case diagram, we map into interface design. Okay, we can map into interface design because from the sentence that you say that actor act to some kind of use case, so we can use that sentence. We can use that notation to design the interface design. Okay. The interface is not about only UI, okay? It's not user interface, but any kind of interface that used to interact to another external interface, okay? In class-based elements such as class diagram, we know as analysis class diagram can be represented into different level. Component level diagram to architectural design and data class diagram, something like this, okay? In analysis, we have analysis class diagram. In design, we have design class diagram. Okay. They are using the same model, the same diagram, but represent in different level. Here is analysis and design. Okay, design process. Okay, design process. Design cannot be done within one time. Okay, just only one iterative. There are many iterative process through from converting from requirement to blueprint. We call blueprint. Here we are talking about blueprint. They represent some kind of class. Okay, you learn about coding or programming. You know, blueprint is a class. So we try to translate some kind of requirement that represent in terms of high-level abstraction explanation to be a blueprint. Okay, one blueprint can create several things, object, right? As we know. Okay, so the design process is the iterative process, or we can say that incremental process that cannot be done within one time. So we have to do many times. Okay, repeating and repeating until we satisfy with the result or output of the design, and then we can move to the development phases. Okay, the process of translating the requirement into a blueprint for constructing a software. This is the design process. Okay, they represent in the design is represent at high level of abstraction. So they will the design mostly they will explain you about the level of abstraction, something that high level, okay, not too low level, but it's a little bit between requirement analysis, okay, a level that can be directly traced to the specific system or requirement object, and then more detailed data, functional and behavioral requirement. This is that we call the high level abstraction. The thing that we have to consider also about the design is we have to be able to track back to the requirement. Okay, for example, we have 10 requirements, so the design should be what we call implement all 10 requirements. Okay, and then we can track to that requirement one is which design is implement that requirement. This is we call directly trace to the specific system object and more detailed data, functional and then behavior requirement. In design process, so we have to consider also about quality. Okay, the quality such as here I represent the design must implement all the explicit requirement, exactly what requirement is. Okay. The design must be readable, understandable guide. Okay, you design something that it should be readable, should be something that easy to understand. Okay, easy to follow or understandable guide. The design should provide a complete picture of the software, say, such as the data, functional, behavioral domain from the implementation perspective. So after we design the phase of implementation, we'll take the design and then do implementation. So we have to make the clear picture of the software design. This is what we call design and quality. Three main things of the design quality. Okay, we have a design quality guideline that you have to follow. Okay, that recommended you to follow. First is the design should be exhibit an architecture. Okay. They should represent the architecture, that existing architecture. Okay, the architecture design or the architecture style or pattern. There are many architecture pattern and design that we can use it. That as if you are working with the web development, you will familiar with MVC. Okay, model wheel controller. Okay, this is one of architecture design. Okay, or architectural pattern. A design should be modular, okay, that separating from the small part to be from the big part to be small part. We call a modular. Okay, a design should contain distinct representation of data architecture and interface component. So after we have the modular design, so it should be distinct representation that can be direct from one to another. It should be a relationship between another, but there should be distinct also. Okay, they should not merge all at the same place. Okay, this is we call distant representation. The design should lead to data structure that are appropriate, okay, for a class to be implemented and draw for recognizable data pattern. Should be in data structure they represent some kind of data and data type. What kind of data that will be represented in terms of design. This is also that we have to consider. Okay. A design should lead the component that exhibit independent functionality characteristic. Okay, should be independent. Okay, component should be independent from one another. Okay, a design should lead to interface that reduce the complexity. The modern design of system they try to implement interfaces. Okay, from the component they provide the interfaces. You want to use that component, you try to use the interfaces. Okay. The design should be derived using repeatable method. Okay. If you are using one method, for example, you are using agile, so you should be follow the agile from the beginning to the end. Okay, it should not be take from one to another combined together. It will be more difficult to implement. Okay, as they say here, that driven by information obtained during software requirement analysis. So it should be taking the requirement and then requirement analysis and design according to that data. Okay, that a design should be represented using a notation. Okay, at the beginning of design, okay, they are represent design in terms of text, so it's difficult to explain, difficult to express to understand. So it's better to use a notation such as UML diagram. Okay. There are also design principles that you have to follow. Okay, the design process should not suffer from tunnel vision. It should not start from 1, 2, 3, 4, 5. You can go by 4, by 3, by 2, or by 5, something like this. You should not follow by step, but you can be mixed from another step. Okay, the design should be traceable to analysis model. This is the main thing that there are many publication or book that say that your design should be traceable to the analysis requirement. Okay, we have many requirements, so your design should be traceable. Okay, should be able to track back that this design is served with requirement. Okay, the design should not reinvent the wheel. Okay, your design, you should not do something new. Okay, it will be better if you do something that you see the problem from the requirement analysis, so you will see the function that they have to be implemented. So according to that requirement, so you will find the solution that already exists. So try to design based on that pattern or based on that way. Okay, this is we call not reinvent the wheel. Okay, for example, you want to design the login function, right? There are many people already design the login function, so you should go and study that thing better than you try to do something new. Okay, that force you to what we call use a lot of energy to do the reinvent the wheel. Okay, the design should minimize the intellectual distance between the software and problem and as it exists in the real world. Okay, the main design is try to make the clear picture of the requirement. Okay, and then represent to the development phase. So it should be minimize the intellectual distance between software. Okay, from requirement to the development. This is the main point of the design. The design should exhibit uniformity, okay, and integration. It should be implement some kind of integration between one to another. Okay, from one component to another component, it should be to be in terms of integration. Okay, the design should be structured to accommodate change. Okay, the design should be structured to degrade gently even when the aberrant data event or operating condition are encountered. Okay, design is not about coding. Okay, design is not about coding, it's about designing. Remember this one, design is not about coding. Coding is not design. Okay, understand this point, right? Someone said that design is about coding. Okay, if you learn, someone said if you learn about software engineer and then you don't know to code, mean that you are fail about software engineer? Not really. Okay, because in software engineer you try to gathering the requirement and then try to analyze and design. Okay, and then propose to the programmer. It will be better. It will be option if you know the code and then you know the programming, so you can do nice better design. Okay, the design should be access for quality as it being created not after the fact. So when you design something, you should use the quality guideline to follow the quality at the beginning of the design, not after that. Okay, because of what? Because of when we face problem after design complete and then we do the implementation phases, it will take a lot of cost to redesign again. That's why we have to consider at the early beginning of the design instead of after the fact. Okay, the design should be reviewed to minimize the conceptual semantic error. Any kind of design you should be reviewed again and again to see and then to minimize the error. Okay, during the design. Okay, the process also how to reduce the error during the design. Okay. Okay, design concept. Design principle is something that you should be respect when you want to design any system or any web application or whatever system or product that you have to design from the requirement to design and then to development. So it will be your guideline. There are different book represent different guideline. So this is the summaries of several book that can be represented here, the design principle. Okay. Okay, design concept. This thing little bit more interesting about I call this one a fundamental of design concept. That when you want to be a designer, software engineering in the level of design, okay, software architecture or software analysis, the thing that you have to consider, there are many things that in design concept that you have to consider and you have to take care. Okay, the first is about abstraction. Okay, everything should be abstract. For example, if I say motorcycle, this is abstract. If I say car, this is abstract. I should not say Honda or Isuzu, something like that. It should be motorcycle or car, and then we can use with several branches of the motorcycle. Okay. Fundamental design concepts. There are many fundamental design concepts. For example, here we have abstraction. Okay. Everything should be on abstract level, data, procedure, and control. Okay, architecture, the overall structure of system. This is the main thing that we will discuss for today. Okay, after we focusing and then we talk about the fundamental. Okay, architecture will be the structure of the system. Okay, pattern is something that proven design solution. Okay, you found some problem that and then you want to solve that problem. Try to find something that someone already done. We call pattern. Okay. You wanna do cooking, for example. You wanna do tom yum, right? You don't need to reinvent the wheel. Okay, you don't want to reinvent or try to do new thing about tom yum because someone already proved that thing. We call pattern. Okay, the proven design solution. Separation of concern. In large system, so we should not do design in one single complex system. Okay, one single code base. So it should be split to be small things. Okay, from the separation of concern, they will divide to be into pieces. Okay, that pieces we call modular. Okay, that pieces become modular. In modular, they contain of data and function. Okay, hiding. Okay, Hiding is about information hiding. This is we call another name we call information hiding. In programming term we call encapsulation. Okay, the control interfaces. Everything hiding behind the scene, but you provide just only interfaces to calculate the thing that someone need. Okay. For example, you will not show your information about yourself. Okay. What you are eating, what you are reading, but if someone talk to you, you can explain the thing that this is we call hiding. Okay, you may not show your how many books you read. Okay, but someone asking about the question, and then you can answer back. This is we call information hiding also. Okay, you do not tell the resource that you read, but you can answer that question. Okay, this is hiding, information hiding or encapsulation. Functional independent. The functional should be low coupling. Okay, the coupling means that the relationship between one another. Okay, one another component. So it should be independent as much as possible. Okay, because of what? Because of when you want to change some things, and then if something that related to another, it will be affect to another things. So it should be low coupling. That's why we say the functional independent. Refinement. Elaboration of detail for all abstract. So it should be abstract should be some more detail that explain about the abstraction. Okay. Aspect mechanism for understanding how global requirement affect design. Okay. This is thing that the aspect for you want to design something. The aspect will come to the concern about the design. What thing that or mechanic that you have to understand before you do the design from the requirement. Okay. Refactoring. Okay. You are focusing about design, especially you are follow the agile, okay, DevOps, for example. Refactoring will be the main topic of your discussion, because when you implement some kind of frequent release of software, okay, maybe you can release feature for many feature for a day, so there will be something that inside trouble about coding, about organizing the code or organizing the component. So you have to do refactoring. Okay, so the reorganization technique that simplify the design. You change the code inside, but do not affect to the behavior outside. This is we call refactoring. Okay, OO design also will be one thing that the fundamental of design concept, object-oriented approach. Okay, that everything should be rely on object. Okay, design classes. This is will be the one of output of the design phases. Okay, one of output of design phase. Okay, we call the design class. Okay, in the analysis phase we have the analysis class. Okay, in the design phase we have design classes. Okay, there we add more detail about the class. Okay, the class here mean class diagram. Okay. Okay, design model. We have many model to follow about the design in software design. Okay, let's see this one. You wanna translate from analysis model to design. What thing that you have to do? Okay, what thing that you have to study or learn? Okay, making understanding about it. If you see analysis model is high level. Okay, design is will be a little bit more low level. Okay. In implementation will be low level. Okay, before we can translate the code to the binary. Okay, to the binary of machine language. The high level, for example, class diagram is high level in terms of analysis model. Okay, and then we have to convert it to such as design class diagram, from the analysis class diagram to be design class diagram. Okay, in terms of architecture. Okay, we can use a class diagram to represent architecture, but they are not suitable. Someone say, okay, the expertise in architecture say that the class diagram is not what we say is not suitable to represent the architecture design. Okay, there have to be another diagram that we can use to represent the architecture. If you see in the design level, we have architecture element, interface element, component level, and deployment level. You can mapping between the analysis model and design model. For example, on architecture element we have class diagram, And then you want to translate from the requirement analysis model to the design model. We can use a design class diagram or subsystem or collaboration diagram. From use case diagram, from interface, okay, interface, you use case diagram or use case text or use case specification. We have to translate it into technical interface design, okay, that consists of UI and UX, something like that. You are design about UI and UX. Or it will be consist of interface that receive data and then display data. We call input and output. Okay. In the component level element, we have class diagram analysis. We have sequence diagram. We have to translate into a component diagram. Okay. This is one of UML diagram, the component diagram, and then design class diagram, activity, and sequence diagram. So if you see, they are using the same many are same diagram but different level of abstraction. Okay, from the analysis level, more high abstraction to design level is low abstraction. Okay, design model element can consider here. One is a data element. Okay, data model. Okay, it can be transfer to from data model. Okay, we can transfer to data structure. Okay, we can transfer to database architecture. Okay, what kind of architecture database you want to implement. Okay, it will be represent the database schema, for example, that represent about the how many table column, how many row that you have to define in terms of data model. Okay, architectural element. Okay, application domain. What kind of application that you want to apply? It will be web application or system or operating system or mobile. It depends. Okay. Analysis class, the relationship, collaboration, and behavior are transformed into design realization. This is the thing that architecture element. Okay. We translate the analysis class to be design classes. Okay. Pattern and style. There are many pattern and style that you have to select and use, and some may be use one single pattern or style. Some may mix between two or more style together. Okay. Interface element design. For example, as UI is one of interface element or internal interface between various design component. Okay, one component to another. There are interface also. But you cannot see via UI, okay, via your web browser or via interface, UI user interface, but they are interacting between one component to another. Okay, a component element and then deployment element. Okay, this is the design model element that when you want to design, you have to follow this one. Okay, start from the data, architectural, interface, component, and deployment. Architectural design, okay, that include many topics that we have to discuss. Okay, architectural design decision, view, pattern, and the application of architectures. Okay, as we know that, and we can summarize that the design can be divided into two levels. Okay, high level design and low level design. High level design is about architectural design, or we call architecture. Okay. In low level design is about detail design, or simply we call design. Okay. In high level design, the output of architectural design will be the architectural pattern, okay, or model. Okay. This is output. Okay. In the low level design, in the detail design, or another name is we call design, it will be the class diagram. Okay, the class diagram. So in architecture, okay, there is we can say that IEEE give the definition for architecture is the fundamental organization of the system embodied in its component, their relationship to each other, and the environment and the principle guide its design evolution. And also ACI, Software Engineering Institute, okay, give the definition of architecture is the structure or the structures of system which comprise software element or software component. The externally visible property of those elements and the relationship among of them. in short, summarize that architecture is the high level design of system that organization of the system, especially here we call component, the group of component, and then organizing the component we call architecture. Okay, because in one application, in one system, there are many components. Okay, and also the relationship between one component to another. How to organize this component into a system we call architecture. Okay. The main focus of architecture is architecture relevance. Okay, architecture relevant that encapsulate many things such as data, classes, procedure, logic, and so on. All we call component. Okay, the data, class, procedure, logic, all can be exposed or can be composed into component. Okay, architectural relevant components affect the overall structure and behavior. If you select one of architecture style, so you have to be work with the architecture, for example MVC, for example layer, okay, client server, something like this. So it will be affect to all system. Okay, if you change this thing, it will change to another. Okay, it will be, if you choose already, so it will be difficult for you to do what we call evolution. So you have to be consider much on this step to choose any architectural design pattern or architectural design style. Okay. Architectural design is concerned with understanding how software system should be organized and designing the overall structure of system. This is the definition of architectural design. Okay, the architectural design is the critical link between design and requirement engineering. Okay, it identifies the main structural component in the system and the relationship between them. So the main point of architectural is tied to translate the requirement engineering, okay, requirement modeling to something design, okay, that we can see via the figure or via explanation in terms of high level design. The output of the architectural design process is a architectural model. Okay, this is output of the architectural design. This for this phase. Okay, in design, because in design we have two level, right? High level and low level, right? In high level architectural design, the output is architectural model. Okay, that describe, okay, how the system is organized as a set of communication component. Okay, most of nowadays they are using agile software development. Okay, so in agile software development, they will consider architecture at the beginning of the design. Okay, they will not consider as the design phase, but they will consider at the beginning of the phase. That is, they will come together with the requirement. Okay, that's why refactoring will be the normal, okay, the normal term in agility. Okay, but why agile software development or agile software process choose what we call doing the architectural decision at the beginning of the phase? Because of when you choose architecture already, when you fail, it's difficult to what we call to redo it again. Okay, so that's why they have to choose at the beginning, and then you can refactoring it again and again. Okay. For example, this one architecture of the packing robot control system. Okay, this is will show you that the architecture, the simple architecture of the packing robot. Okay, the robot that used to packing the stuff. Okay, they will show you like this with a box and then with the relation one to another component. Okay, inside this figure, you can see the many systems working together. Okay, vision system, object identification system, packaging selection system, packing, and so on. There are many systems working together. This one, if you want to explain like this, is we call architecture of the system. Okay. Architectural abstraction, architectural in small is concerned with the architecture of individual program. Okay, at this level, we are concerned with the way that individual program is decomposed into component. Okay, because they are in large and small architecture. Okay, if they are talking about small architecture in small application, so we are talking about decomposed into a component of the application. Okay, if we are talking about architecture in a large, we're talking about the enterprise system. Okay, we are talking about the complex enterprise system, that which architecture pattern that we can use in that system in large and or enterprise system. Okay, why we have to do architecture? Okay, why we have to design the architecture? Okay, first is for stakeholder communication. If we want to show to the stakeholder who is related to our product or our system, architecture may be used as a focus of discussion by system stakeholder. This one, we can use the architecture to use discussion about the system, what the system should be built, okay, how the system can be built based on the architecture. System analysis, use this one also. Large scale reuse, if we design the system without any architecture, so it's difficult to be reused. Okay, reuse means using again. Okay, we do not design one application, one system in one code base. Okay, in one component or in one architecture, but we are design in different component and then make that component working together by interface. So it will be better if we specify the architecture of that component. Okay, then we can reuse the architecture and that component. Okay. Architectural representation. Architectural can be represented in many forms. Okay, mostly they are using line and box and represent in terms of UML. You represent in terms of ADL. What we call a notation or expression can be represented architectural. Okay. And say here the simple information block diagram showing entity and relationship are the most frequently used method for documenting software architecture. Okay, but this have been criticized because they are like semantic. Okay, mean that difficult to explain to another person because the box can be mean many things. Okay, the line can be many things. So we should be represent in terms something that more specific for architectural. Okay, that's why I do not show the type of relationship between entity nor the visible property or entity in the architecture. That's why line and box is difficult to explain the architecture. Okay, depending on the use of architectural model, the requirement for model semantic depend on how the model are used. Okay, mostly we are using box and line diagram to represent the architecture. Okay, but they are lacking in terms of explanation. So we have to find something that more easier to understand. But line and box can be useful for explain to the abstraction level for people who in the level of business, such as stakeholder, manager, or user. Okay, not for programmer. Programmer and coder or developer need something more semantic. Okay, more something that more detailed than that. Okay. Use of architectural model, okay, as a way of facilitating discussion about the system design, as a way of documenting architecture that has been designed. We're using architectural model. There are many models that we are going to discuss. This thing used to use for discussion in high level architecture view. Okay, we will see that our system will look like this. Okay, we consist of many systems that working together. We are this line, okay, that using the line that send and receive the data. This is the thing that we call architectural model. Okay. Architectural design decision. Any architecture that you want to use in your system, You have to make a decision. Okay, decision can be made by many people. Okay, mainly will be made by software architecture. Okay, mainly will be made by software architecture because software architecture will receive information from the requirement from analysis and do the decision that this according to that information, according to that data, this architectural design pattern or architectural design style will be implemented on the system is suitable for that. Okay. The decision can be made by what we call software architecture, okay, but can be also be involved by another person, okay, but mainly is software architecture can make a decision, okay. Architectural design is a creative process, so the process differ depending on type of system being developed, okay. So different software, different architecture, okay, different software architecture, not one single solution for all problem, okay. However, a number of common decisions span all decision process, and this decision affect the non-functional characteristic of the system, okay. One thing that we have considered also non-functional characteristic as security and performance when we want to make a decision about any architecture. So we have to consider also this one, okay. There are many questions, many things to consider before we make architectural design decision, okay. For example, here they say what kind of application you are, what kind of system that you are developed, okay. The system is about distribute across the hardware, core or processor or not, or just web app or whatever, or mobile app. What architectural pattern that will be used, okay. How many person that related to this one, what strategy, what architectural organization is being is best for delivery non-functional requirement of the system, and what will be the fundamental approach use or structure or the system, what data or data type or data structure that using on that system. So this question is have to be answered during the architectural design decision, okay. Architecture reuse, okay. You hear a lot of word reuse that I use in this lecture, okay. Reuse means that something you make it already and then you try to use it again. We call reuse, okay. When we want to apply any architecture, we do not try to reinvent by ourselves, but there are group of people, and then the thing if you want to reinvent, so it should be proof design already, okay. The proof design already, so we can use it. System in the same domain often have similar architecture that reflect domain concept, okay. If you are talking about application on a computer, they are sharing the same concept. If you are talking about web application, they are sharing the same concept. So the architecture can be reused, okay, within the same domain, okay, within the same domain, okay. Application product line are built around the core architecture with variant that satisfy particular customer requirement. The architecture of the system may be designed around one or more architectural pattern or style. One system may be applied for two or more architectural pattern, okay. This capture the essence of architecture and can be instantiated in different way, okay. This is the way how to reuse mean, okay. For example, if we are talking about web application framework, okay, whatever programming right now, they are implement MVC. So if you try to implement architecture of MVC style, so you can be implement for all web framework, okay, web framework, whether Laravel, whether the Django, or whether another name of framework, okay. So it can be what we call reuse, okay, reuse. The things and the system characteristic or quality characteristic that you have to consider when you do architectural design decision, okay. The first is performance, second is security, the third is safety, availability and maintainability. The thing that you have considered also when you want to choose any architectural model or architectural style. Okay, because different style, different model, they prefer you with different point. Okay, different point. Maybe one may be about giving your performance very fast, very response time very less, but the security will be reduced. Okay, but some kind is will be high security because if we need more high security, performance will be reduced by default. This one. So if you wanna choose any architecture design pattern, okay, so this thing you have to consider also. Okay, we call system characteristic. Let's continue our topic. Okay, about software architecture design. This is about architectural view. Architectural view is about view or perspective that we use to see the system architecture. Okay, this is the meaning of the architectural view. Okay, each architectural model only show one view or perspective of the system. Okay, it may show decompose into a module or runtime processing or distributed system across the network. This is the view of each architectural. Okay, different system, different product, they are using different view. Okay, they may view on the high level view, the middle and the low level that we can discuss here. Okay, about we have logical view, development view, process view, and physical view. Okay, they are talking about the same topic. There is architectural design. Okay, but different people, different perspective see architectural in different view. Okay, developer in terms of development, they see architectural view in terms of how to develop the architecture or how this architecture can help in terms of development. Okay, in logical, they see how the system organized into a big system by using component. Okay, in physical is about physical, how one of physical device or one memory or processor or monitor or camera working together in terms of the physical view. They are also architecture. Okay, one system may using hardware to communicate. For example, many applications that using a webcam, many applications that using a microphone to record a voice, they are also using the architecture. So how the system can communicate to that device, there is in the physical view. Right? In the process also, what the process between the component that using, right? There is the in terms of process view, architectural design. Okay. The summary of this thing is different perspective, different view. Okay, you may see architecture in different perspective. Okay, as the designer, we see the architecture in terms of designer. Okay, and developer may see architecture in terms of developer. Okay, this is the short meaning of the architectural view. Okay. View can be implemented as we discussed about 4+1 view, right? We have the 4+1 view model. Especially this view is for software architecture. Okay. Okay. We have a logical view, we have process view, we have development, and we have physical view. Okay. And then we have also one more view. There is a scenarios view. Okay, at the middle of the 4th view model. Okay, and you can see here they say the logical view which show the key abstraction in the system and object or object classes. Okay, the process is about show how at the runtime the system is composed in interacting processes. Development show how software is decomposed for development, for developer can create the software. Physical view is about hardware, system processor, system memory. Okay. We in different view, different perspective, we'll see the different result and different output. So we have to represent the view, okay, represent the architectural view via some kind of notation. For example, here UML we can use for documenting system architecture, but some may say that the UML is not suitable, okay, it's not suitable for describe the architecture view, okay, architecture design pattern. But we have another thing that we can use to describe the architecture is we call architectural description languages, okay, or ADLS, okay. This is for describe the architectural design pattern, okay. You can use UML, but UML actually used for high level description and then for class diagram, for detailed design class diagram, but it's not suitable for the description or representing the architecture design, okay. Architecture pattern, okay, as we say, patterns is the solution proven, okay, proven solution that someone before us found that this problem can be solved by this solution. We call pattern, okay. There are many patterns over there. There are more than 100 patterns that you can use to solve a problem that occur, okay. You may no need to reinvent the wheel by yourself, but someone already faced the problem, so we can solve the problem based on the solution that someone tried to explain they face already, okay. This is we call pattern. So in architecture they have pattern also, we call architectural patterns. Patterns mean representing or sharing the reusing knowledge, okay. As I say that someone before us found they faced the problem, okay, they faced the problem, so they try to solve the problem again and again, and then they found the best practice solution to solve that problem. They collecting to be a best practice or guideline that we call pattern, okay. Architectural pattern is stylist description of good design practice, which has been tried and tested in different environment. Architect already test the pattern that this pattern is nice and the pattern is suitable for the problem already. So if you face the same problem that someone faced already, so use that pattern better than try to what we call found the solution by yourself, or we call you don't invent the wheel, okay. Pattern should include information about when they are and when are not useful, okay. Pattern will describe you that this pattern is using for what and this pattern is not suitable for what, okay. The pattern may be represented using tabular and graphical description. It can be represented by using graphic or tabular or table, okay. Let's see the most famous pattern that using nowadays for application, especially for web application, we call MVC, model view controller pattern, okay. You see here the main point of MVC is they try to separating the presentation, separating the model and the controller, okay, to be each component, okay. We call MVC, model view controller, okay. When to use this one? We can use this one when we want to separate it, okay, from the model. Model means using to connect to the database, okay. The controller means using to controller, okay. When you receive something from the request, and then you try to control which way you should go, and then you pass that way to the view and view the data, view the interface to the user, okay. This is we call MVC, okay, MVC pattern. Then you see this one, the table, okay. The table we have the name of pattern, and then we have description of the pattern. We have example when we can use this one. When example of the pattern, and then when use this pattern, advantages and disadvantages. Okay, so all the pattern that represent on this slides will be represented as this table. Okay. MVC, as you see here, the architecture of web-based application system organized using the MVC. Most of web-based application they are using MVC. Okay, MVC. Okay, we can. There are also many another web framework using layer. Okay, pattern such as Spring from Java EE. Okay, Spring Boot they are using layer, not for model view controller or MVC. Advantages of this using MVC is that allow the data to change independently of its representation, and vice versa. Support representation of the same data in different way, with changes made in one representation show in all them. Okay, this is advantages of this pattern that you request same thing, they may represent you in different way. Okay, so it we call independent. Okay, independent representation. Example as you can see here, this is the organization of the MVC pattern. Okay, and you see we have view, we have controller, we have model. Okay, the model is used to render the model. Okay, request model update, send user event to the controller. Okay, the controller is used to map user action. For example, user requests some action to the software or system. The controller will take the action and then guide to which part that you want the request one to modeling, or it related to database, or it related to some kind of data. It will send to model, and then we'll view the data via view perspective. Okay. Web application architecture using the MVC pattern. You see this one, web browser request to as user you you visit any website, okay, that implement MVC. It will contact to controller that using HTTP request. Okay, and then if that request need also database from the database, okay, need data from the database, the controller will call to model. Okay, and then it will view to the view. Okay, view to the view. Okay, it can be dynamic pages, can be dynamic page generation, form management, or some kind of such as login form or whatever, and then you can do interact with the browser. Okay, you see this one. You see the most famous pattern. Okay, architecture pattern or architecture style that implement for web development. Okay, web application development. Okay. Layer architecture. Okay, the layer architecture can be divided, organized into a set of layers. Okay, set of layers. They divide into a subsystem. Okay, by layers. Okay, one layers connect to another layers, and then another layers the second layer connect to the third layer like this, and then they exchange the data to the interface. Okay, we call layer architecture. The layer architecture is organize the system into layers with related functionalities associated with each layers. This one, this is this description and explanation of the layers architecture. Okay, this one is an example of layers architecture. Okay, it can be, for example, here they say user interface is the top layer. Okay, user interface management, authentication, authorization will be the second layer. Core business logic, application, functionality, system, utilities is the third layer, and the last layer will be system support, OS, database, and so on. This is the layer architecture. The Spring boot, and then Java Spring they implement layers architecture. Okay, and another layer is you learn about networking, right? There are, in computer network there are OSI 7 layer, right? They are implementing the layer architecture also. Okay, from the application layer to physical layer. Okay, this is example of iLearn system or iLearning system that implement the layer. Okay, you can see the first layer is a browser-based user interface. Okay, or the application of the system, and then they connect to the second layer, and then to another layer, and then to another layer. This one, they will divide into the layer, and the lowest layer is mostly will be about the database. Okay, the database. Okay, then each layer the name of it. For example, here they have the browser base that come from the web browser. The second layer will be configuration service. The third layer will be application services, and the last layer will be utility services. This is, and then for each layers there are the function that provide it. Okay, so each layer they are working with the interface, connecting from the top to below, and then from below to the top. This is layers. Okay, we have another architecture pattern that we call repository architecture pattern. Okay, all the main point of repository is share data. Okay, in central database. Okay, this is the main point of repository architecture. Okay, when large amount of data are to be shared, the repository model of sharing is most commonly used, as this is the efficient data sharing mechanism. Okay, as if we want to share data to be a center. Okay, and then all client or another component using that data. Okay, we call repository architecture. Okay, pattern. As description here, repository pattern. Name is repository pattern. Okay, repository architecture pattern. All data in system is managed in central repository or database that is accessible to all system component. Component do not interact directly, only through the repository. Okay, this is the description of that pattern. If you see something that all they are sharing the same data, and then data will be the center, and then all component using that things is we call repository pattern. Okay, for example, as IDE they are using this pattern to design the integration development environment, and you see you can use NetBeans, for example. You can use VS Code, for example. If you convert it to be IDE, that is using this thing also. If you are using GitHub desktop, they are using this also repository pattern, because all data stored at the center place, and then if you want to use that data, you come to join to that data. Okay, you see this one is an example of repository architecture for an IDE. Okay, project repository will be center. Okay, we have one project to the center, and then all another component come to join, come to edit, come to modify the data of the project. Okay, come to modify the project repository. For example, one project can be using multiple programming language. For example, here Java editor, Python editor, design, translator, UML, code generator, and so on. Okay, but the project repository or the database will be the center, sharing the same thing. Okay, this is a repository architecture pattern. Client server architecture. Okay, this one the client sharing. Okay, request will be client will be the request. Okay, the server will be response. Okay, so the server will be stand over there, and then you want something, you can request to the server, and then server will respond back to the client. Okay. You can see this one network. All network connection they are using client server architecture. Okay. You want to connect to the internet connection. You want to connect to any network. This is the architecture they are using. Okay. You request to the server. Okay, and then server will reply back to you. Whether the HCP or the internet connection or whatever, they are using this pattern, client server architecture. Okay. Description of this pattern is in a client server architecture, the functionality of the system is organized into service, which is service delivery from separate server. Client are user of these services and access server to make use of them. Okay, client used to access to the server to use the services. Okay, the server will be a person who serve the service. Okay, we call the client server pattern or client server architecture pattern. Okay, you can see here. Okay, this is the client server of architecture for a film library. Okay, you see here there are many features available, right? You can see a catalog server, video server, picture server, web server. Okay, a client can be many client. Okay, you wanna use any services from you wanna use any servers from the internet, so you have to connect to the internet and then use that services. Okay. Pipe and filter architecture. Okay. Functional transformation process their input into product output. Pipe filter. Okay, there are pipe and filter. They the consist of pipe. You know pipe, right? I think everyone know pipe. Okay, pipe will be the pipeline that send and receive the data. Okay, the filter will be who will be control the data inside the pipe. Okay, this is we call pipe and filter architecture. Okay, the description of the pipe and filter pattern is the processing of the data is the processing of the data in a system is organized so that each processing component filter is discrete and carry out one type of data transformation. The data flow as in the pipe from one component to another processing. Mean that the data inside the pipe will be will send through the pipe, right? The data will send through the pipe, and then the filter will filter the data will pass or not. Okay, will pass this filter or not, will pass this stage or not. We call pipe and filters. Okay, this architecture pattern. You can see here. Okay, you see any kind of something similar to this, we call pipe and filter architecture. Okay, this is example of payment system. Okay, from one step to another step. Okay, before you go to another step, they have to identify, right? Identify or verify that you are qualified to pass this step or not. Okay, the data that sent to another step we call pipe. Okay, we call data that using pipe, and then the filter that using to identify we call filter. Okay, we call filter. Application architecture. Okay, how can we implement the architecture? Okay, this is example here. Example of how can we implement the architecture. Based on this, we have there are different domain. Okay, different domain of requirement can be implemented different way. Okay, for example, here application system are designed to meet an organizational need. Okay, so when we want to implement or we want to make the application of architecture, so we have to consider the organization need, okay, or business need. As businesses have much in common, their application system also tend to have common architecture that reflect the application requirement. Because business, whatever any kind of system, whatever requirement, they are sharing the same thing. Okay, they are sharing the same thing. So the generic application architecture for type of software system, they may be configured, adapt to create a system that meets specific requirement. Because they are sharing the same thing, so we can use with one architecture pattern can be used with several application requirement. Okay, but there may be some kind of a specific requirement. So we have to take the existing architecture pattern and adapt. Okay, make it a little bit modified to serve that specific requirement. Okay. Use of application architecture, okay, as a starting point for architectural design. Okay, we use architecture pattern to be as starting point of architectural design. Okay, as the principle, the concept say that you should not reinvent the wheel, right? You should take the architecture already exists, okay, and then try to modify that point. Okay, try to modify that point if you are got some specific requirement. Okay, as a design checklist. Okay, as a way of organizing the work of development team. Okay, as a mean of assessing component for reuse. Okay, as a vocabulary for talking about application type. So when we try to implement the architecture, so there are the vocabulary. Okay, that when we talk about this thing, it means this thing, okay, it means that thing, okay. It's not about, when we talk about, for example, we talk about architecture. The architecture is about organization of the system, right? It should not be another meaning, otherwise the team will be confused about the vocabulary. They will miss communication on the team, okay. Example of application type, okay, this can be the famous application type nowadays: data processing, transaction processing, event processing, language processing system. Okay, this is the famous and the essential and become common application that using nowadays. Okay, data processing. Okay, the data driven application, any kind of application that using data to drive. Okay, whatever kind of database, whatever kind of data, this we call data processing. Okay, transaction processing application. Okay, they are using data center application that process user requests and update information in the system database. You see the selling, buying, transaction banking system. There are kind of transaction processing. Okay, they are the transaction processing application. Okay, event processing system application where system depend on interpreted event from the system environment. Okay, language processing system application where the user intention are specified as a formal language that is processed and interpreted by the system. Most of language processing system is a compiler, is one of example. Okay, they translated from programming language to machine language. Okay, or if you see the translator, okay, for example, Google Translation, they are using this technique, okay, language processing system. They translated from one programming language to another. This is example of language processing system. Okay, a chatbot also is kind of language processing system. Okay, the most famous and the most generic widely used application architecture is there are two type of application architecture. There is a transaction processing system and language processing system. Okay, for example, transaction processing system such as e-commerce, reservation system, flight system, what we say, hostel, food delivery, something like this we call transaction processing system. Okay, in language processing system, as a compiler, common interpreter, this is example of the what we call language processing system. Okay, you say transaction processing system process user request from information, okay, for information from a database or request to update the database. This is the transaction system. If you see something that you make transaction, okay, transferring money, buying something, okay, ordering something on the internet by using network, some kind of network, that we call transaction processing system. Okay, in transaction processing application, this is the architecture of the that application. There is a transaction processing application that start from application logic. We have I/O processing, application logic, transaction manager, database. This is the application that we can implement through the architecture pattern. Okay. For example, we have ATM, right? Everyone use ATM. Okay. Or someone never use ATM. Okay. I think no, right? Everyone ever use ATM, right? You see this one? This is the architecture of transaction. Okay, architecture of transaction processing system. Okay, we have input, processing, and output. Okay, from the input is the user get customer ID, right? Wallet card, select service. Okay, you insert your card and then you validate the card, right? By entering some kind of PIN. Okay, PIN or password. And then select service what you want to do, withdraw or deposit, and then the processing we query the account, update account, and then the output we print detail, return card, dispense cash. Okay, for example, you withdraw. Okay, dispense cash. Okay, this is the example of ATM system that represent in terms of transaction processing system that implement the software architecture. Okay. You can represent architecture like this, okay, like this. We have input, processing, and output. For each input, there are what we call a component, okay, the component that represent inside. Okay, we have customer ID, wallet card, and select service, and so on. Information system architecture, okay. Information system architecture is one kind of transaction-based system. Also, we can say that it's a kind of information transaction-based transaction processing system. Also, okay. There are layers include the user interface, user communication, information retrieval system, database. Okay. You see this one? They divide it to be the layer. Okay. They divide the system to be a layer. So they're implementing the layer architecture pattern. Okay. You see this one? Layer information system architecture on that example. Okay. We have user interface. You have user communication. We have information on that we want to retrieve, and then we want to modify, and then the database that you to access the data. Okay. This is layer information. That one application of information system. Okay. Information system. Any kind of information system that you develop. Okay. So they try to, in this case, they implement the layer information system architecture. Okay, they implement layer architecture pattern. It will look like this. Start from user interface, and then user try to access any service that provided by the system, and then the system will validate that you are authorized or you are the right person or not to retrieve the information and modify the information. Okay, and then they have the database also, one layer that we call database transaction management database. Okay. Okay, we have mental care system. This is another example of implementing the layer architecture pattern. Okay, from web browser login, from web browser you do login, and then do any kind of feature. For example, report generation from the database. Okay, patient database, transaction management database. Okay, you see this one. They divide to be layer architecture pattern. Okay. Web-based information system. Okay, web-based information system also they connected to web-based. They are using some maybe MVC, some maybe can be layers also. Okay, but everything will be accessed via web browser. Okay, web-based will be accessed via the web browser. Okay, for example, e-commerce system, delivery system, something like this. This is called web-based information system. In server implementation, mostly server implementation they are using client side or server architecture. Okay, or layer architecture. Mostly they are using client server architecture. Okay, you can see that if you wanna request some kind to use server, you request, right, as user, and then the server will reply back to you as response. Okay, as response. Language processing system. example as artificial language. Okay, they used to translate from one form of language to another form of language. For example, I speak in English. I want to translate to Thai, so we have to use this system. Okay, language processing system. Okay, translated from English to Thai. Okay, in computer also we can translate it from syntax. Okay, of the programming language to machine language. Okay, they are using language processing systems. Okay, you see this one, the architecture of language processing system. There are many things that related to this system. For example, source language instruction, translator, abstract instruction that used to translate it, and then interpreter, data, and then feed, execute, and resolve. This is one of the what we call interpreter. Okay, interpreter, programming compiler that used to translate the programming language to machine language. Okay, this is the architecture that they display. Okay, they show to us. Okay, as simple as they say a compiler. Okay, compiler, that we know that the compiler will use the syntactic, right, and then semantic, converting our programming syntax that we coding. Okay, and then translate it to make computer understand what we need. Okay, what we need. Okay, we have lexical analysis, we have symbol table, we have variable, class name, object name, and then we have information, we have checking error, syntax check error that is correct or not. Okay, and then the syntax will be compiled. Okay, will be compiled. Okay, this is another example of repository architecture for language processing system. Okay, they consist of many things: semantic, syntactic, lexical, format, editor, optimizer, code generator, and then come to the same place. Okay, all sharing the same repository. Okay, that's why we call repository. Okay, everything will be the center database, and then you want to use that thing, and then require it and use it. For example, here they show us about the language processing system. Okay, this is the pipe and filter compiler architecture. Okay, this is the implementation of pipe and filter compiler architecture. Okay, from lexical analysis, then you can lexical is mean something that what we call human readable, human understanding. Okay, syntactic will be something syntax, if else something, this one we call syntactic. Semantic, okay, that is more meaningful, and then can generate to be code. Okay, can generate to be the code. This is the pipe and filter compiler architecture. So this is the thing when we compile our code. Okay, from human to code, or from human to machine. This is will be follow. Okay, start from lexical, syntactic, semantic, and then code. Okay, to be machine language. Okay, or you want to translate from one language to another. Okay, from English to Thai. This is the way we doing. Okay, the way we doing. So you want to implement for language translation. Okay, it's suitable that you try to use pipe and filter. Okay, architecture pattern. Okay. Okay, summary. The software design is about translating the requirement model into design model. Okay, software design process is an iterative process which requirement translated into blueprint for constructing the software. Okay, software design concept include such as abstraction, architecture pattern, separation of concern, and modular, and so on, information hiding. Okay, software design model can be design model principle, data design, architecture design, interface design, component level design, and deployment level design. Okay. The architecture is description of how the software system is organized. This is the main point of the architecture. Okay, software architecture. They used to describe the system, how the system is organized into a big part. Okay, there is a component. Okay, how if we say another word is how a component organized. Okay, to make it suitable for that requirement. Okay, this is the main point of the software architecture. Okay, we have to do architectural design decision to make a decision that what kind of architectural style or pattern that going to use for that system. Okay, the architectural may be documented from several different perspectives. Okay, one person from another perspective will see architecture in different view. Okay, designer will see the architecture in another view. Software engineer or developer will see the architecture in another view. Okay, so if you want to do documenting the document, if you want to documenting the architecture, make sure that the will be one standard one. For example, we can use the ADLS or UML diagram. Okay, architecture pattern is something that already solved by someone. Okay, problem that solved by someone, and then they propose to us to be a pattern that you will face this kind of problem, so please use this pattern. Okay, because we already proved that this solution is good enough for that problem. We call architectural pattern. Okay, that we have many type of architectural patterns, such as we say pipe and filter, we have MVC, we have layer, and so on. Okay, for each one they have advantages and disadvantages. It depends on the system that you are developing. Okay, the main system that we are facing nowadays is there are two types. Okay, transaction processing system and language processing system. If we look at that system, they implement a lot of architecture. Okay, architecture. For example, transaction processing system such as information system that implement layer architecture pattern or MVC pattern. Language processing system that implement layer also pipe and filter also it can be implemented. Okay, this is the key point or summarize for this lecture about software design. Okay, this is the class of the software design. Thank you for your attention. See you again for next lecture. Bye bye.